Hi class, my name is Kevin McKnight, and this week in Cyber 4220, we'll be discussing Imaps protocol and DNS protocol. So going over the agenda for this session, we'll be covering Imaps protocols, configuring Imaps on Linux, hardening Imaps, DNS protocols, configuring DNS on Windows, hardening DNS on Windows, configuring DNS on Linux, and hardening DNS on Linux. Imaps protocols. So IMAPS is the Internet Message Access Protocol secured is the secured version of the standard email protocol, IMAP. The main difference between IMAP and IMAPS is that IMAPS uses SSL and TSL encryption to provide safe message transport between a client and the server interaction over port 993, whereas IMAP does not encrypt and uses port 143. IMAPS exists in the application layer of the Open System Interconnection, or the OSI model, and allows users to access email messages on a remote mail server. Email messages are stored on the mail server unless explicitly deleted by the end user, which allows for the use of both offline and online modes by which the email client, by ways of the email client and the internet. Configuring IMAPS on Linux. In order to configure IMAPS to use SSL and TSL encryption, a certificate must be installed to allow the secure connection and transport between the server and the client. For example, the RSA self-signed certificate can be created on a mail server and stored in the IMAPS configuration along with the private key. On a Linux distribution such as Ubuntu, IMAPS can be configured using a service such as Dovecot, which is a secured open source mail server. Dovecot contains built-in functionality to enable SSL and TSL encryption and can be configured in the 10-ssl.conf file. Once the trusted or self-signed certificate has been created and placed in the appropriate directory, the 10-ssl.conf file may be edited. Also, to ensure that IMAPS is the only protocol in use rather than IMAP, the dovecot.conf file should be modified to include the following line: protocols equal IMAPS. So now we're going to go over some hardening techniques that you can implement on your Ubuntu system for IMAPS. The first one is to digitally sign and encrypt your emails. So digitally signing and encrypting your emails prevents anyone from intercepting and reading your emails, and it makes sure that it's only opened by the person you sent the message to. The next is to disable open relaying on virtual servers. So open relays allows other email servers to use your server as a gateway to others. This allows others to send like spam email that may appear to be coming from your address, which could lead to your address being identified as a spam source. So the best way to prevent this is to just disable that feature. And then the last tip here is to enable Sender Policy Framework, which is SPF. So the purpose of SPF is to recognize spam and forged emails, and this service prevents automated spam emails from reaching the user on the email server. So now we're going to touch on DNS protocols. So the domain name system, or DNS, is the phone book of the internet. Users access information online through the domain name, like NewYorkTimes.com or ESPN.com. Web browsers interact through internet protocols or IP addresses, and DNS translates domain names to IP addresses so browsers can load internet resources. Each device connected to the internet has a unique IP address that other machines use to find the devices. So the DNS servers eliminate the need for humans to memorize IP4 addresses or even more complex newer addresses such as IP6. The process of DNS resolution involves converting a host name, such as ksu.com, into a computer-friendly IP address, such as 192.168.1.1. An IP address is given to each device on the internet, and that address is necessary to find the appropriate internet device, like a street address is used to find a house. When a user wants to load a web page, a translation must occur between what the user types into the web browser and the machine friendly address necessary to locate, let's say, ksu.com. Okay, so continuing on with DNS protocols. So DNS uses three different types of queries during a lookup. There's recursive queries, iterative queries, and non-recursive queries. In recursive queries, a DNS client requires that a DNS server will respond to a client with either the requested resource records or a error message in the resolver if the resolver can't find the record. Iterative queries, in this situation, the DNS client will use a DNS server to return the best answer it can. If the queried DNS server does not have a match for the query name, it will return a referral to the DNS server for a lower level of the domain namespace. And so the DNS client will then make a query to the referral address, and this process continues with the additional DNS servers down the query chain until either there's an error message or it times out. Non-recursive queries. Typically, this will occur when a DNS resolver client queries a DNS server for a record that it has access to, either because it's authoritative for the record, or the record exists inside of its cache. Typically, a DNS server will cache DNS records to prevent additional bandwidth consumption and load on the upstream servers. Configuring DNS on Windows. So DNS is one of the industry standards of protocols that comprise TCP and IP. And together, the DNS client and the DNS servers provide computers name to IP address mapping, name resolution services to computers and users. DNS is part of the application layer of the TCP and IP reference model, and is very important to day-to-day operations of computers all over the world. So Windows servers allows DNS to be configured through the Windows Internet Information Services, which is the IIS. And Windows IIS is pretty straightforward when it comes to installing a DNS server, as the user would just have to add the feature and specify the server roles, all within the IIS application. Hardening DNS on Windows. So here are a couple of techniques that you can implement in your server in order to harden DNS on Windows. The first is to enable DNS socket pool. So the DNS server has a pool of sockets which the source port pulls from. This feature randomizes the source ports for DNS queries, preventing attackers from knowing which ports to use and decreasing their probability of guessing the port being used. The next is to enable DNS recursion. And so DNS recursion is used to assist the server in resolving the search name or domain names. And this task is completed by communicating with other DNS servers to find the name or address of the website. Although the service can be useful, it leaves your server at risk by keeping the server open, which allows it to be vulnerable to potential attacks. And the last tip here is to enable DNS SEC. So DNS SEC is a DNS security extension that authenticates and strengthens responses for DNS lookups with digitally public key signatures. Configuring DNS on Linux. For Linux, we'll be using the Berkeley Internet Name Domain, which is the bind software, to configure the DNS server. It is the most popular DNS server software for Linux products that is also open source. Bind is used to publish DNS information that resolves DNS issues and translates domain names into IP addresses. The terminal prompt to install Bind is sudo apt install bind 9. Once installed, the primary configuration file can be located at /etc/bind/name.conf. Hardening DNS on Linux. So here are 3 techniques you can implement on your Ubuntu server to harden your DNS servers. The first is to hide the bind version banner. By hiding the version number, this will prevent attackers from knowing which version of bind you are using should there be any type of exploits for that particular version of bind. The next is the ACL. Enable the ACL, which is the access control list, which allows users to define who can access the name server. This allows the ability to give specific users to the user's domain or parts of the website to control the flow of traffic or prevent potential DOS attacks. And the last tip here is to run bind in a chroot environment. And so a chroot environment allows bind to run in a sandbox environment, isolating it from the rest of the server to limit security risks should there be a server, or should your server become compromised, excuse me. And here are my references, and thank you guys so much for your time.